10.3, the Pythagorean Theorem. In mathematics, you will hear the word theorem, especially in geometry, used a lot. The word theorem means rule, so anytime you see the word theorem, we're talking about just a rule of mathematics. Now, this rule is made by Pythagoras. That's why it's called Pythagorean Theorem. He was a Greek mathematician that developed a rule when dealing with right triangles. So we have a right triangle. Whenever you have a right triangle, it'll be noted by a 90-degree angle or a little box in the corner. And the Pythagorean theorem says that in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Now that sounds confusing, and you don't need to write that down, but you do need to write down the triangle. Now in the triangle, we have a few sides. The first thing is the hypotenuse. The hypotenuse is indicated by the letter C. The other two sides are called legs. So we call those A and B. Now they are also interchangeable. So this leg right here, leg A, and leg B, they can be interchangeable for B and A. So it doesn't matter. However, the C is always the longest side. So a couple things you need to know. The first thing is this. The hypotenuse is the longest side and the side opposite the right angle. So you'll notice, here's the right angle, it's opposite the right angle. Next, the legs are the two sides that form that 90-degree angle. So here's a leg and here's a leg. They form that 90 degrees. Therefore, A and B are your two legs, which form the 90-degree angle, and the third side, which is across from the right angle, which is also the longest side, is called your hypotenuse. So our formula is A squared plus B squared equals C squared, which states that in any right triangle, the sum of the square of the legs is equal to the length squared of the hypotenuse. In the next few examples, we're going to find the missing lengths, and we're going to take our answer and round it to the nearest tenth. Something you're going to notice is that a lot of your assignments are going to mention to put your answer in simplified radical form or simplest radical form. We haven't done that yet. We will. So what I want you to do is ignore those if it ever says that and just round it to the nearest tenth, unless otherwise noted. Example number 1. We are given a right triangle with lengths of 15 feet and 8 feet. And we want to find the third angle, or the third side. So now if we look at this, we need to first realize that what are we trying to find? Well, we're trying to find the longest side. And if you remember, the longest side is across from the right angle. And that's the side we need to find, which is called the hypotenuse, which is our letter C. So if we use our formula, A squared plus B squared equals C squared, we know that this right here, 15 and 8, can either be A or B. It does not matter which one of these is A or B. So let's plug in 8 for A squared, which is 8 squared, plus B squared, which we're going to let be 15, equals our third side, which is C squared. All we do now is simplify it. 8 squared is 64. 15 squared is 225 equals C squared. 64 plus 225 is 289 equals C squared. Now, once again, the opposite of squaring something, which you should know, the opposite of squaring something is taking the square root. So we have to take the square root of both sides. And you guys know that the square root of C squared is C. And the square root of 289 will give you 17. Please remember that we have to label. So our answer would be 17 feet. Example number 2. We have a right triangle with sides that are 3.5 kilometers and 6.5 or 6.5 kilometers. Now, if we're looking at this one, the right angle is now up here. Therefore, the side across from the right angle is the hypotenuse. So that means 6.5 is the hypotenuse. And our two legs are 3.5 and the side we need to find. Keep in mind that just because 6.5 is on the bottom does not mean it's a leg. This triangle is turned around, so our hypotenuse is on the bottom. So we can either solve for A or B. So if we have A squared plus B squared equals C squared, let's plug in 3.5, 3.5 for B, so be 3.5 squared, equals C, which is 6.5 squared, and just solve the equation. A squared plus 3.5 to the second power is 12.25. 6.5 to the second power is 42.25. Subtract 12.25 or 12.25 on both sides. You get A squared equals 30. Last step is taking the squared root. Now if you take the square root of 30, you are going to get a decimal. So A is going to equal the square root of 30, which is approximately 5.5 kilometers. And we made sure we labeled it, so let's circle that, and that's our answer. Now we can also put this. Approximately, we can put our little approximately marks if you want, the two wavy signs. So A is approximately 5.5. It's actually 5.47 and so on. But if we round it in the nearest tenth, it will be 5.5 kilometers. In example number 3, we also want to find the missing side, which in this case is A. But we notice that one of our sides, which is our leg, is the square root of 8. So if we set this up, we're going to have A squared plus B squared. Well, B is the square root of 8 equals C squared, which is 10. So C is 10, so we have C squared, which is 10 squared. Now, if you remember, inverse operations, they're opposites of each other. So if I square a squared root, the square root of 8 squared means I am taking the square root of 8 times the square root of 8, which is the square root of 64. And the square root of 64 is back to 8. So really what just happened is that our squared root with the squared cancel each other out. So what you're left with is just 8. Whenever you square a squared root, they cancel out. And then equals 10 squared, which is 100. We subtract 8 on both sides. We get A squared equals 92. And then we take the square root of 92. And we get A equals 92 is approximately 9.6. And that would be your answer. A 6-foot ladder is leaning against a building. The base of the ladder is 2 feet from the base of the building. How far up the building is the ladder resting? Now you are going to have quite a few applicational problems on Pythagorean Theorem over the next couple of days. What you're going to have to do is you're going to have to draw a picture, and they're all going to be different, and then realize from your picture where is the right triangle, and from there find the missing side. These are going to be a little more difficult. So let's think about what we have here. We have a building. So here's our building. And we have a ladder that is resting on this building. Now you do not need to make a great picture here, but there's my ladder. We know that ladder is 6 feet. We know the building is going to be 90 degrees with the ground. And we know that the base of the ladder is 2 feet from the base of the building. So now we have to realize, what do I need to find? Well, I need to find out how high up is this ladder resting on the building. And that right there, right here, is our right triangle. So if you notice, we have a 6 and a 2. Are we trying to find A, B, or C? We're trying to find either A or B, one of our legs, because 6 is across from the 90-degree angle. Therefore, that's our hypotenuse. So let's solve for A. A squared plus 2 squared equals 6 squared. That gives us A squared plus 4 equals 36. Subtract 4, A squared equals 32. And then we take the square root of both sides. And we get approximately 5 7/10, or 5.7 feet. And that is our answer. The ladder is resting approximately 5.7 feet up against the building.